Alright, today we are going to talk about the Pythagorean Theorem. This is not a geometry standard, this is an 8th grade standard that you missed because you took Algebra 1 in the 8th grade. Now you might have heard of the Pythagorean Theorem and used the Pythagorean Theorem before, and that's great, but just to make sure you know how to use it and what's going on, we are going to do that today with some example problems. We're going to do 1, 2, and 3 together, then you're going to finish the rest. I will show you the answers when you show up to school either on Monday or Tuesday, depending on which group you are in. But this is not going to be an assignment. It is just going to be you are going to watch me do 1, 2, 3. You are then going to finish them yourself. We're going to talk about putting them in your notebook, and I'll let you check them later. Okay, so it's not an actual grade or assignment or anything like that. It's just review work. If you still need help after this, just let me know, we'll figure it out. Alright, first of all though, in the Pythagorean Theorem, you need to know what the Pythagorean Theorem is, and it is a squared plus b squared equals c squared. A and b are legs of a right triangle. This only works in a right triangle. This is the hypotenuse. The hypotenuse is directly across from the right angle. So for instance, this is the hypotenuse, 15. Okay, it's also the longest side. So we're going to work with this one, set it up, find out what BC is. So let's say this is A, let's say this is B, and this is C. Okay, so 12 squared plus B squared equals 15 squared. Go ahead and square them. 144 plus B squared equals, I believe it is 225, but I better check. Yep, 225. Okay. I'm going to subtract 144. You would miss this if you set it up A, B, C. Make sure you notice which one's the hypotenuse. 225 minus 144 is 81. So B squared equals 81. To undo squared, I take B square root. And the square root of 81 is 9. So BC is equal to 9. Okay, we're going to try number 2. Here is C. A and B don't matter as much, C does. So 2 squared plus 5 squared equals C squared. 2 squared is 4. 5 squared is 25 equals C squared. 4 plus 25 is 29. And we're going to take the square root. Normally, I would take this time to teach you how to find radicals. I don't know if you understand what I mean, but there's a way to find a perfect, what this is perfectly. If you know what I mean, tell me. If you don't, we'll figure that out. We need to work on that later. So second square root, 29. It says, round the answer to the nearest tenth. Now, you're going to follow whatever the sheet says, but normally I hate that, and I would want it to the nearest fourth, 4 decimal places, not fourth, 10th, 100th, 1000th, 10,000th. I like it here. So it would have been 5.3852, but we're not going to do that. It's going to be 5.4. The reason bridges collapse is people round too soon. Definitely they didn't round at the 10th. They might have rounded all the way down here. But bridges collapse if you don't round. If you round too much, don't round too much. All right. Another thing to keep in mind, when you're rounding something, never round until you get to the answer. Don't sit here and round, and then your answer will be so off. You only round when you get to the end. Okay, let's label number 3. Then we're going to glue this in because you're going to finish it by yourself. Now you're going to finish it and then glue it in instead of what I'm doing. But all right, this is C, A, B. So A squared plus 6 squared equals 9 squared. That looks like a B. It's a 6. A squared plus 36 equals 81. 81 minus 36 is 45. A squared equals 45. I got to take the square root of 45. Use my calculator, second square root of 45, and I get 6.7. Okay? So you're going to finish this. You're going to ask me for help if you need it. Okay? I'll be available during your class period to answer questions for you. Alright? But we're going to cut this out around. You don't need the name because it's going in your notebook. The reason we're putting this in your notebook is you need some examples of Pythagorean Theorem, but also because Pythagorean Theorem is related to what we were doing on Monday, the distance formula. I want you to come back to school on Monday and be able to tell me how the distance formula and the Pythagorean Theorem are related, even if you have to look it up. So look up and see if you can determine how the distance formula and the Pythagorean Theorem are related, okay? You need to make sure you have turned in your problem set by the end of class today, whatever that time is. Don't let it be late, because remember, late work is not allowed in honors classes. So if it's late, it's a 0. You don't want a 0 for your first test grade, because the problem set is a test grade. I will post the new problem sets on Monday. Now that I got that cut out. On page 12 is where we're going to glue this. And we're going to label it 1.2 distance formula, even though this is the Pythagorean Theorem, because you're going to come to school and tell me how the two are related. I probably should have glued this in before I wrote it down. Yep, see, it barely fits. I shouldn't have done that. It's okay. Page 12, 1.2 distance formula. I know, it looks really weird. It's alright. Glue that in there. It's okay. If it sticks out the bottom a little bit, just fold it up. Mine doesn't, but fold it up. Then I'll be okay. Alright, I will see you on Monday. Make sure you got the answer to that question.